Doing business with Syncnet. To give a brief history, we started back in 1987 and are celebrating our 27 years. We've developed over 50 database software systems, consulted on hundreds of projects, large and small. Our web-based eBiz management system has had over $300 million transacted through it, and our database systems collectively have transacted close to $1 billion. We have a couple policies that you need to abide by. If you want a custom application is really a living entity and will require ongoing maintenance forever and updating forever. We have no contracts to lock you in, but you need to plan on a monthly expense long term. Because things change, business processes change, the world changes, and it's going to require updates to your systems. Understand that there's nothing secure on the web. You can call Cisco, you can call the best firewalls out there, and ultimately, if you drill down far enough with their engineers, you'll find out that basically there's no such thing as anything being secure on the web. Security is all based on layers. Just as you have layers of security for your house, you have layers of security for your internet systems. So let me give you an example. With your house, your first layer of security is actually a door with a lock on it. Now, if you have a lock and a door, it does give you some indication of or feeling of security. However, if anyone wants to get into your house, can they still get into your house? Sure, they can break a window. You could put bars on the window. But let's assume you do that. You've got bars on the window. You now have an alarm system. You have locks on your doors. Can someone still get into your house? Absolutely. All it would take would be a little C4 or crashing into the house, or taking a chainsaw or taking a saw and cutting into the windows, whatever. You have to understand that at any point in time, if someone wants to get into your house, they're going to do it. But we feel secure because of the layers of security that we have in place. Likewise, on the internet, there are layers of security. We have firewalls. We hide databases behind. We take care of all the things on the front end where people can put in SQL injection code or cross-site scripting hacks. There's a bunch of things we can do that give us a level of security. However, there's no such thing as security, and if anybody wants to get in and steal whatever they want, it's going to take a lot of work. It's very difficult. It's only for super experts, but it can be done. And you know that it can be done because it's done. You know, the CIA's been hacked, FBI, government, Target, you name it. Everybody's been hacked. And the most important thing I would say is to keep a low profile or a low footprint so that you don't become on a hacker's radar. That's probably the best advice I can give. But we do all the things that give you a level of security. We do all those things that we just mentioned to keep your data safe and secure. But realize that there's nothing secure on the web. We do build every 2 weeks. We run on Microsoft Windows Server environment, and we use code generators whenever we can. And we'll talk about why that's important. Number one, we have a project management style. We were actually introduced this before the year 2000, and it was called the DSDM, the Dynamic System Development Method, which today has been adopted as what people call as Agile. And it is a project management methodology that allows you to get stuff done on time and on budget, which American project management philosophy has not been very successful in doing. In fact, whether you know it or not, 75% of all systems developed since it was recorded are failures. So the success rate of software development projects is quite low. But this is a method that you can use to increase that. So here are some of the project success barriers of the past. The project had lack of focus, there were unclear requirements, there were time overruns, cost overruns, there was lack of ownership, there was problems with defining who the roles of the individuals that were on the project. There were changing specifications. there was scope creep. Things kept coming, and as things changed, it hindered the success of the product. There's also a thing called gold plating, where you're trying to add really super cool stuff to make something super cool, and it may not be necessary for the success of the project in the first place. It's also one of the big problems was creating a product in search of a market instead of the other way around. So let's talk about the philosophy of DSDM. The traditional way is that you had fixed functionality and variable time and resources. Now, what does that mean? That means that you would set up the system, and you'd say, okay, this system it's required that it has this and this and this, and it has to be able to do this and this and that and that and this. And the problem with that is some of the functionality that may be required, there may be one thing that's requested that takes longer than the entire rest of the system to produce. And it may not be actually necessary for the business process to be completed. So the problem with fixing your functionality, which is what everyone wants to do, is that then time and resources become variable. And that is why you have cost overruns and you have time overruns. You don't get it done on time. So be prepared for this new philosophy, and the way it works here is that you fix time and resources, and what becomes variable is functionality. So you just turn this upside down, and I'll explain how that how that works. The way you do that is you prioritize your products. You've got what we call the Moscow technique, which is must, shoulds, coulds, and basically won'ts or woulds. And a must is something the project must have or it will not succeed. A should is it's good to have. We would like to have it, but we do have a workaround that we can make it work if we don't get that done. And then coulds are fun but not necessary for function. And then the W's, which you can call woulds, but for the most part are won'ts, are things the project basically are not ever going to have. Let me give you an example. If Microsoft had waited till today we're at Microsoft Word version, I don't know, probably 12 or 13 or something like that. And if they had waited to get all the features and functions of Microsoft Word 13, they would have lost out on all the money that they would have made when they launched Word, 20 years ago and took over the market. So understand that when any software product is launched, it's always the version 1.0. And the reason that Microsoft, they didn't wait till it's at this level. They launched it at version 1, and people bought it. They got feedback, and then they implemented some of that feedback. And then, every couple years, in their case, they use a 3-year cycle, which is a little bit long, but they release a new version every 3 years, and you have what we have today in the current version of Microsoft Word. And that's the same goes for every software product. You need to understand that there are things that are important that make it that make the product functional, and then there's things that you're just not going to get to that can be added later on in a different segment that we'll talk about. So let's talk about just very quickly what a must would have been on a word processor. You need to be able to edit. You need to probably have a spell check. That would be a must. You need to, although it's probably a should actually if you think about it, because as long as you can, if we talk about the basic functionality of a word processor, you need to be able to type in text. You need to be able to edit text. You need to be able to save it out. You need to be able to print it. And those would probably be the musts. Shoulds would be, it would be really cool and nice to have a spell checker, but there's the workaround on that is you use a dictionary, for example. A could might have been the ability to automatically generate a table of content based on the content. that's been typed in. So that should give you some ideas about some of the differences in defining and prioritizing what needs to go into the final product. So let's talk about prioritization. In this method, we put everything in what we call time boxes. And these time boxes are fixed time elements. So let's say, for example, that we're going to say that we're going to release every 30 days. So what we would do is we would prioritize, we'd figure out what needs to take place, define what needs to go in this iteration, this next section that we're going to release, and then we would prioritize. Now, using the Moscow technique, we would give some of the options musts, some of them shoulds, some of them coulds, and then some of them woulds or won'ts. And you can only have 20 to 30% musts in any time box. So in the next 30 days, in the next 30-day time box, only 20% can be musts. The shoulds and coulds, you can have as many of those as you want, because what's going to happen is as we get closer to the 30 days, as things get added on because of change, the coulds start to drop out because they're not going to get done in this time frame. And eventually, because you're working on the things at the bottom, which are the musts, and as we get closer to time, and as you know, people keep making changes, or you know, they want to the business changes, or whatever may take place over time, the shoulds eventually start to drop over the top. So but what we get to is the musts that should have been done originally to make the software fit for business, fit for fulfilling a particular purpose. And if we have time after the musts are completed, then we go ahead and we work on the shoulds and the coulds. So hopefully that makes sense. So in this case, time stays constant, but functionality changes based on our prioritization. So consider this being a time box here. What we need is we create a feasibility study or a business study based on the needs of the customer and determine what needs to be done. We then prioritize using the Moscow technique, assigning the musts, shoulds, coulds, and woulds, and then a maximum of probably 30% can be musts. We then create a functional model of what this function is supposed to happen, what the software is supposed to do. And from there, it then goes to design and build. And so there's an iteration. It's in a very short time frame. This is also given a very short time frame. So if the guys who are assigned to create the functional model or the design, then whatever they get done based on the date that they've been assigned is going to be whatever gets to happen in that particular iteration. It then goes to design and build. They have a certain, a very short time frame from which to design and build, which of course is the reason why we like to use code generators, is because the time frame is so short to be able to deliver, to be able to test, especially the complex systems that are developed today. You've got to be able to have something that is already time tested. So code generators help do that. The next phase, which is an important phase that most people miss, is the implementation phase, where you actually have to get people trained and implement and actually put it out in production and get people actually converted to using it. Make sure they're properly trained and that they understand. And then it goes right back in this circle. We then take a look, and after we get feedback from the people who are now it's now been implemented and are now using it, and we find out what changes they would like to make or what things they'd like to see. And we go through this entire process once again. And ideally, in my opinion, the best way to do this is in 30-day increments. And so all time frames are very, very short. and you basically every 30 days you go through this a time box where you create a new functional model of whatever the new functionality you'd like to add. You've Moscow, you've prioritized using Moscow, given it must, should, could, would, and won't, and then you give it to the programmers to design and build, and then we get handed off to an implementation team who's going to get implemented and make sure that people are properly trained on the new functions, and then we go through the same process every 30 days. And that process basically goes on forever. So you have to be committed to the process. The ultimate objectives of DSDM is to reduce the time to market, to improve quality, increase productivity, reduce development costs, and increase cooperation, teamwork, and job satisfaction. You do have to have active user involvement. So the team that's set up, these are small teams, so that there's not a lot of arguments about what should be going on. You have to come to consensus very quickly. You need to have team empowerment. They need to be able to have the power to make the decisions and not have to rely on upper management to be able to get back because the time frames are so short. There is frequent product delivery. You have to make sure that the things that are being designed have a fitness for business purpose, meaning that you're not just creating a bunch of really cool charts because that'd be really cool, but you're doing it because you're doing something because it actually fulfills a business purpose. This is an iterative and incremental production model, so it's very short, and it's always you're basically going in the circle of the iterative process that we talked about in the time box just before this slide. All changes are reversible, so if something is implemented, ideally, this is not always possible, but ideally for a successful DSDM project, the changes need to be reversible in the event that something gets implemented that ended up being a bad call or bad decision. So you can go back to the previous version. Requirements are baselined at a high level, so we're not talking about going into little teeny details. The high level requirements would be that for this software to fulfill its purpose, you need to be able to schedule an event and and be able to take payments. That would be creating the requirements at a high level. The individual screens and those will be designed in the iterative process in the time box. You need to be able to test throughout the development cycle, and of course, collaboration and cooperation among the stakeholders is extremely important for the system or the process to be successful. So there are other things that are important to the success of a project. The system characteristics in and of itself, they have to be interactive with functionality at the user level. The system has to be clearly defined at the user group level, and it cannot be computationally complex. For example, if you writing the Google algorithm, the algorithm that Google is using today is extremely complex and could not be written in a 30-day period, nor could it be written. They've been using the same agile process in the Google algorithm since they started, and so the version they have today is 10 years more complex. It actually took them 10 years to get to the algorithm they're using today, and so just be aware of that. So if you do have something that's computationally complex, they took their original version and broke it into a smaller version. However, understand that Google probably they took out their 1.0 version and released it to the public, and then got feedback and figured out better and more effective ways to change that algorithm. You need to be able to break the system into smaller functional components. It needs to be able to have time constraints placed on it, and requirements have to be prioritized and defined at a high level. And if you do these things, you're going to have a successful product. So for this to be, one of the critical success factors is that the team has to have decision-making power. They have to accept this dynamic system development methodology philosophy. There is a serious commitment from all the users involved. They need to drop whatever they're doing when a question comes up from a developer, for example, so that he can get the questions answered as soon as possible so it doesn't slow down the process. And the organization has to support incremental delivery. The team has to have access to all the end users, has to be stable and focused. It can't be very unstable where you've got a lot of change or people who are moving in and out of the organization. The team members have to have the appropriate skills. The team size should be less than 5 members. And obviously, technology has to be adequate for prototyping, which is why, of course, we like to use code generators. We charge $150 an hour for, if you happen to be an eBiz customer, that's reduced to $100 an hour. You can also buy blocks of time at reduced rates, as you can see below. And we would love to help you on your project. This is the way we do business here at Syncnet. If this philosophy doesn't jive with the way you do things, then we're not a good fit, and that's okay. There's other people who do follow the waterfall project management methodology. They don't have a very good success rate, so we can't highly recommend them, but once again, we want to make sure that we're a good fit for you, and this is the philosophy that we abide by. And for you to be successful, if we're going to be the guys to help you on your project, this is the philosophy that you need to be willing to accept and understand, and we'll have a great time and have a lot of success together. Thanks.